Okay, let's talk about the unit circle. We've seen this before, but I wanted to go over a few things um, and get us started with the unit circle here. So today we're going to be creating some reference triangles. We're going to find the reference angles. We're going to state the 6 trig ratios for each of those angles, and then we are going to be converting between degrees and radians. When we talk about angles on the unit circle, we are referencing them to the x-axis, okay? So this graph kind of shows you where they fall in the different quadrants, but notice that every time it's in relationship to where the x-axis is, the closest x-axis, okay? So we're going to talk about that a little more when we draw our reference triangles. So we are going to create a reference triangles by drawing the angle in standard position. Remember, that means we're starting at 0 and we're rotating around, okay? If it helps you to convert to degrees, that's fine. I would really like you to get comfortable with radians because we're going to do a lot in radians, but we'll work on that. Then we're going to make a right triangle by connecting the angle to the origin and the x-axis, okay? And then we're going to calculate the reference angle by finding its distance from the x-axis. So we're going to walk through a couple of these and how to do them. First off, we have 210 degrees. So let's start by drawing that in. Excuse me. That would be in the third quadrant. Because 210 is between 180 and 270, okay? So I'm going to connect my angle theta to the x-axis, which gives me a right triangle. Now I want to find out what theta is in relation to the x-axis. And remember that this one is 180. So from 180 to 210 gives me a 30-degree reference angle, which means that what I'm dealing with is a 30, 60, 90, okay? I'm going to draw it over here so it's a little bit bigger. And then remember that we need to label with negatives the appropriate pieces. In this case, it's both legs because we're going left and we're going down, okay? And so now that we have got our reference triangle, we can list out our 6 trig ratios. Now, it is important that when you do this, you're writing sine of 210 because we need to specify what the angle is, okay? It's not just theta anymore, it is 210. So we need to make sure that we are writing this appropriately. And then we're going to go through and we're going to label all of the, or we're going to state all of the 6 trig ratios. So I've done sine, and I'm going to do cosine and secant. You do not have to rationalize it, so you can leave it as a square root of 3. That's totally fine in the denominator. Whoops. And then tangent is opposite over adjacent, and then cotangent is the inverse of that. And here I told you to write it, and then I forgot to do it. Sorry. Okay. So we stated our 6 trig functions. That is all we're going to do for right now. That is good to go. Okay, let's try another one. This time we have 45 degrees, which is in the first quadrant. So I'm going to draw in my triangle. That's a 45, 45, 90. All the sides are positive because I'm in the first quadrant. And so then once I draw my triangle, I'm just going to list my 6 trig ratios. Okay, so I'm going to start with sine, cosine. The nice thing about sine and cosine for the 45, 45, 90 is that they are the same. So that makes life a little bit easier. And then I'm going to go through and I'm going to list the inverse ones as well. Don't forget those, okay? Okay, so there we go. I got my 6 trig ratios down here. Negative 225. So remember that when you're doing that, you're rotating backwards. So that would be in the quadrant right here in the second quadrant, okay? Because what I'm doing is I'm going 225, but I'm going this way. And then I'm going to draw in my triangle. Oh, whoops, sorry. 225 from 180 is 45, meaning that I'm dealing with a 45, 45, 90 triangle. And then this piece is going to be negative because it's going left. Okay, and then I'm going to list my 6, not 45, whoops. Get my eraser here. Oh my goodness. Sorry guys, I'm having some issues here, obviously. It still needs to be the sign of negative 225, not 45, which I started to write because I wasn't paying attention, because we are talking about the trig functions of negative 225, okay? So don't forget that piece of it. And don't forget to actually put the angle as well. That is important. And then go ahead and list them out. I'll do that real quick. Negative 1 over square root of 2. And then don't forget to be careful about your negative signs as well. Don't lose those or forget them, okay? It's kind of important. So now we have 120, and that is going to be in the second quadrant. And the distance from 180 to 120 is 60. So I have a 30, 60, 90. And I'm going to label my sides. Okay, just be careful with a 30, 60, 90 just to make sure that you put the right stuff in the right spots. And there I go, trying to write 60 again. It's 120. And that is equal then to square root of 3 over 2. And then we have cosine and secant. And then we have tangent. Excuse me. Okay, so there we go. We got our 6 trig functions. We can also do reference triangle with radian measures. And here's where I'd like you to get kind of comfortable with radians, okay? So let's draw this out. Remember that this is pi over 2 at 90. Then we have pi. Then we have 3 pi over 2. And we have 2 pi, okay? So 2 pi over 3 is going to put me into this quadrant here, okay? And it sometimes helps if you convert into degrees, or if you want to, just on the side here, I'm going to sketch my special right triangles. Excuse me. So the 45, 45 is pi over 4. Oops. And then the 30, 60, 91, 30 is pi over 6, and 60 is pi over 3, okay? So if that kind of helps with your triangles, and then of course, this is going to be a pi over 3 because I'm starting with a 2 pi over 3. So the nice thing about radians is that the denominators always match up. So if I have a denominator of 3, that's going to automatically be a pi over 3 or 60-degree reference angle. And then I can kind of go from there. That's kind of helpful, I think, to be able to relate them that way, okay? So, I don't know if that's a helpful hint or not, but that's what I've got for you. And then we're going to list our 6 trig ratios. Don't forget to write it of 2 pi over 3. And then don't forget to write all 6 of them. Then we have tangent. I think the hardest part about this is just writing the stuff down. It takes a little bit of time, and that's okay. All right, so there's that one. Let's try another one. 7 pi over 6. So 7 pi over 6, 7 over 6 is greater than 1. So no, I know I'm either in the third or the fourth quadrant, okay? And if we kind of, I don't know, I've kind of learned to count by like sixes, if you will, for this one. So we've got 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. 7, 6 is going to be here. And then, of course, that's a reference angle of pi over 6, which makes this one pi over 3. And then I can label my pieces, and both of the legs are negative, okay? I'm going to let you fill out the 6 trig ratios for that. I think you know what you're doing there. The hardest part here is drawing the reference triangle, especially using radians. So I want to show you another one of those. Negative 7 pi over 4 means that we're rotating backwards. So this becomes pi over 2, this becomes pi still, and this becomes 3 pi over 2, okay? And we're doing pi over 4s. So starting from 0, there's 1 pi over 4, 2 pi over 4, 3, 4, 5, 6, 7. Oh my goodness. I just lost my thing. Anyway, so negative 7 pi over 4, would be right here in the first quadrant. And the reference for that is a pi over 4 triangle. And then you can list out your 6 trig ratios for that, okay? So just kind of think about how your radian measures work and get kind of comfortable counting them out in radians. Again, if you feel like you really want to convert to degrees every time, you can. I won't be upset about that, but that's up to you, okay? I would like you to try to get more comfortable with radians, okay? So 5 pi over 3 is bigger than 1, but not bigger than 2, right? Because 2 pi would be 6 pi over 3. So then this one's kind of interesting. So you have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, and 6. So 5 is going to be in the fourth quadrant here. And the reference angle for that's going to be a pi over 3, which means this one is a pi over 6. And then this is going to be a negative square root of 3. So if you can kind of like figure out how to do it in radians, that's really helpful, especially because some of the other stuff we're going to do with solving and such is in radians, and it's helpful to know, okay? We'll continue working with this, but I would like you to work on this, try to do some of the example problems on your own, and then do your assignment, okay? And we'll talk more about this later.